Hi guys, this is your foldable for subtracting integers. So you have your foldable and the first thing we need to do is fold it. So I actually want you to flip it to this side and you're going to take the top part and you're just going to fold it down to the line. So you're going to take the subtracting integers part and then fold it down. And then you're going to take the bottom part and you're going to fold it up to that line. So it looks like this. And then for cutting, we're going to undo this part. And we're going to take our scissors and we're going to cut until we reach the fold. Okay, so next thing, we've got our foldable done. We're going to start filling it out. So today we're going to learn about subtracting integers. And if I'm ever going too fast, please pause the video and catch yourself up. If you have questions during the video, you should write a question mark where you had the question, make a note of what it was so that you can ask me when I see you in class the next day. So subtracting integers. To subtract integers, we're going to use the additive inverse. And that is just fancy terms for what I will say all the time in class, which is leave, change, opposite. You'll hear me oftentimes say LCO. This is the important one. Using additive inverse is just fancy terms for leave, change, opposite. And I'll show you exactly what you need to do. It says, note if you are subtracting two positive integers and the larger number is first, you can subtract like normal. So then we have some examples here. So we're going to lift up tab number 1. And here you can see a subtraction problem. It says 5 minus negative 8. So we're going to use the additive inverse. In other words, we're going to rewrite the problem using leave, change, opposite. So what that means is the first number I leave alone. I'm going to write it the same way. So I'm going to say 5. And then instead of subtraction, we're going to change it to addition. And then here it's a negative 8, so we're going to change it to its opposite. And the opposite is positive 8. So this is its additive inverse. The additive inverse of 5 minus negative 8 is 5 plus 8. It's changing your sign to addition and the opposite of that second number. So then I go ahead and solve. 5 plus 8, oh, I know that's 13. So B on here, negative 12 minus 5. I'm going to use my additive inverse, my LCO. I'm going to leave the negative 12. I'm going to change the subtraction to addition. And right now this is a positive 5, and I'm going to make it a negative 5. So now it says negative 12 plus negative 5. And this is why yesterday I told you it was super important to learn our adding integers rule. Because when you're subtracting, you're actually adding. So you have to know those rules. So here I see that my signs are the same. They are both negative. And remember, when signs are the same, you add the numbers. So 12 plus 5 is 17. And you keep their sign. They're both negative, so my answer is negative 17. So let's try C. Negative 4 minus 7. I'm going to leave the negative 4, change to addition, and then this is a positive 7. I'm going to change it to a negative 7. So I wrote the additive inverse. And now I'm going to use my addition rules. My signs are the same. Same means sum, so I'm going to add the numbers and get 11, and I keep their sign. Negative 11 is the answer. D, 8 minus negative 8. Okay, I want to write the additive inverse, so I'm going to leave, change my subtraction to addition, and then I have a negative 8 here, which means I'm just going to make it a positive 8. So I'm just going to write 8. Oh, that's easy. 8 plus 8, I know, is 16. So if I have 8 and I take away a negative 8, that's actually going to give me the number 16. Letter E, negative 2 minus 13. Okay. So negative 2, change it to addition. The opposite of positive 13 is negative 13. This is its additive inverse. It's LCO. So now I'm going to use my addition rules. My signs are the same. When they're same, that's a sum. So I'm going to add them together, and I'm going to keep their sign. Negative 15. Okay. So all of these examples, notice that when we made the additive inverse, the signs were the same, so we add. Okay. That will not be true for example section 2. So we're going to do the same thing. We're going to leave, change, opposite, right? It's additive inverse. So if I have 4 minus 7, I'm going to say leave the 4, change the minus to addition. Now I have a positive 7. I now want to make it a negative 7. So here's my LCO, my leave, change, opposite. Then I'm going to use my adding integers rule. So my signs are different. Different means difference. So I'm going to subtract. 7 minus 4 is 3. And then I'm going to look. 7 is larger than 4, and 7 is negative. So my answer would be negative 3. 4 minus 7 is negative 3. Let's try B. Okay, additive inverse. Leave the first number, change to addition, the opposite of the second number. So this is a positive 19, so I need to change it to negative 19. My signs are different, and different means difference, and difference means to subtract. So my 19 minus 15 is 4. 19 is bigger than 15. 19 is negative, so my answer is negative 4. Letter C, negative 8 minus negative 3. So its additive inverse would tell us to leave the negative 8, change the subtraction to addition, and the negative 3 becomes a positive 3. So I have negative 8 plus 3. Now I use my adding rules. When the signs are different, I subtract the numbers. 8 minus 3 is 5, and take the sign of the larger number. 8 is bigger than 3, and 8 is negative, so my answer will be negative 5. Right, next one. Negative 1 minus negative 6. Additive inverse says leave the negative 1, change to addition. The opposite of negative 6 is positive 6. My signs are different, so I'm going to subtract. 6 minus 1 is 5. 6 is larger and 6 is positive, so my answer is a positive 5. Let's try it one more time. 9 minus 17. The additive inverse would tell me to leave the 9, change the subtraction to addition, change the positive 17 to a negative 17. Again, my signs are different. So when my signs are different, I subtract. 17 minus 9 is 8. 17 is larger than 9. So since 17 is negative, my answer would be negative. 9 minus 17 is negative 8. Hopefully we're catching on to these. And tomorrow when I see you, we're going to practice this with chips and a number line so you can actually see what's going on. So let's do example flap 3. Now, these I feel like I can answer really fast because look, 5 minus 4, 12 minus 10, 4 minus 1, 13 minus 5, 7 minus 2. And for sure, if you can answer these really fast, which you should be able to, you don't have to write the additive inverse. I can say this is 1. I know 12 minus 10 is 2, and 4 minus 1 is 3, and 13 minus 5 is 8, and 7 minus 2 is 5. You can answer that quickly because you learned that a long time ago. But let's look at the additive inverse. If I were to write this and you didn't know what you were actually doing the whole time was adding the additive inverse. You were saying leave the 5, change it to addition. The opposite of positive 4 is negative 4. And then look, if I use my addition rules, Signs are different, so I subtract and keep the sign of the larger number. Leave, change, opposite. Signs are different, I subtract. 12 minus 10 is 2. Take the sign of the larger number. Leave, change, opposite. Signs are different, so I subtract. 4 minus 1 is 3, and I take the sign of the larger number. Let's try it 2 more times. Leave, change, opposite. My signs are different, so I subtract. 8, take the sign of the larger number. And finally, leave, change, opposite. I subtract. I take the sign of the larger number. So that is the rule for subtracting integers. We're going to practice this a whole bunch the next time I see you in class, and then we'll learn how to model subtracting integers also.